Okay, continuing chapter 7, section 1, with example 7-1 here on page 373. So I'll read the setup. It's pertaining to the number of days that it takes to sell an AVO. I'm not a car guy. I'd have to ask my wife on this one. A researcher wishes to estimate the number of days that it takes an automobile dealer to sell a Chevrolet Aveo, a random sample of 50 cars at a mean time on a dealer's lot of 54 days. Assume the population standard deviation to be 6.0 days. Find the best point estimate of the population mean and the 95% confidence interval of the population mean. All right, so right here you can see I've copied down the pertinent information. Chi bar is equal to 54, right? That is n is equal to 50. Now notice here we don't know mu, but for some strange reason we do know sigma, right? This will seem, if it doesn't seem weird right now, or if it doesn't seem weird when I say it 58 million more times. It'll seem really weird when we're trying to come up with uh, an estimate for sigma or for the variance, the sigma squared, based on what we have in our sample. We'll say, oh, wait, oh yeah, why did we just get to assume that? But in this first example, or in this first section, we're going to be assuming that we know sigma. So that gives us the capacity to use our standard normal curve, right? At first, though, it says the best point estimate. So the point estimate, what is a point estimate? Remember, a point estimate is just a single value. Point estimate for mu would be approximately 54. Just whatever our sample told us, that's going to be the one number that we can throw out for the population, right? And that doesn't give us very much. So what we're going to do is, as a follow-up to that, we're going to say the 95% confidence interval for mu. Okay? So how do we do that? Well, just go back through the steps. 1 minus alpha is equal to 0.95. Right? So subtract 0.95 and then also add alpha to both sides. So we'll get alpha over here on this side. We'll do 1 minus 0.95 over here on this side. Okay, go ahead and switch sides. Alpha equals, and let's simplify as we do that. Hopefully it didn't skip too many steps there. Okay, and so then the last thing is, what is alpha over 2? Right? Because our critical z values are going to be looking at the tail ends of the normal distribution. Okay, so here's the idea. There's 0, and that's where we're going to stick chi bar, right? And over here on this side, we're going to do chi bar plus a little bit. Okay, over here on this side, it's going to be chi bar minus a little bit, like so. Okay, and our interval is going to be everything that's in the middle, right? So from here all the way over to here, all of those x values are going to be potential potential values that mu could possibly be. So essentially, we're going to be 95% confident that mu is going to be somewhere in this range here. So only 5% of the time would we expect that it's in the lower range here or the upper range here. Okay. So the remember, we're doing this so that we know this left area here is 0.25 and this right area here is 0.025. I should have said that right on the other one as well. Okay, so here I'll pretend to go away and look these up. Okay, I'm back. The critical z subscript alpha over 2 values, and you could write z subscript 0.025 if you wanted to, would be plus or minus 1.96. So remember, this is our favorite example, so we're going to have this be our favorite z value ever. All right, so the first thing that I do is I construct my error, my margin of error. So the margin of error is going to be the z subscript alpha over 2, right, times whatever sigma was. Remember, we're assuming that we know that, times the square root of our sample size. So in this particular case, it's going to be 1.96 times 6.0 in place of sigma, okay, divided by the square root of 50 for our sample. And here I will pause to get my calculator. Okay, so here I am, I'm back. I don't know if you can see it on the calculator, but I've rounded this to 1.7. So our margin of error is 1.7. And then the sloppy way that I write it is mu equals chi bar plus or minus the margin of error. Okay. That's just to make me remember that mu is going to be in the middle, okay? And then we're going to read this twice. Okay, we're going to take our chi bar, this, what we found for the margin of error, this one, 1.7, and add it, right? So that would be 55.7 would be the upper bound. And then read it again, but this time we're subtracting away the error bound. So this time it would be, what, 52.3. Take 54 minus 1.7 gives us 52.3. All right, so that would be the 95% confidence interval for the average number of days that it takes to sell a Chevy Aveo. Okay, so we'll pause, or we'll end this video here.